So all good. Okay. Yeah, today, guys, we are going to learn more about relational databases. I know you know this concept from your previous Java lectures, but as I understand, we have to refresh it, and I will help you with it. So let's go. What is basically a relational database? It helps you with organizing your data. So you can use other tools to organize your data for applications, but it can be a bit hard to manage it. And when you integrate that into your application, you can get some problems that your structure is not stable, for example, or your columns in your table, they don't work as expected. They don't have such data type as your application expects. Because when you developed your fast API application, for example, you had particular data types that you want to get in order to work with the data. And if something goes wrong, it will break the whole program. So that is why we need to structure our data correctly. And here is actually an example. I know that a lot of you had some experience with Excel spreadsheets. And you know that it's like unorganized data because we don't know the structure of this spreadsheet. And as this first screenshot, as you can understand, we don't know what to expect. The person can input anything, and we will not know how to process this data. So that is why we need to create some tables and to ensure that the structure is stable and we know what to expect in our application, and we store the data with some predefined structure that we are expecting. As you can see here, we have this table and in example with customer ID, first name, last name, age, and country. So in such way, we are enforcing that our table has only this data and that our fields have particular type, and you will get to know how to organize it. So what is structured data? You can see here a bit more explanation how it can look like. So your table has a lot of components. And for example, from the very left side, I hope it also, okay, it's right in screen sharing. Yeah, you have your row. So row is just a record. For example, it can be any data structure. You can have your library, yeah? And for example, it can be books. So books is some organized entity, and a particular book is a one row where you store the information about this book. It can be author, title, year of publishing, or something like that. So row is a one record in your table. What is primary key? I think it's really important thing. So if you store your books, you want to be sure that there is no clashes. So if a book can be called somewhere in application, you want to know that you are working with this exact instance. So ID is like unique identifier for your row. So in such case, when you have, for example, your update API, and you are targeting your book by ID, you want to be sure that you are targeting one exact book and not other books. So that is why you need this ID row to identify exactly one row. Okay, column is this exact attribute field that can be book name, can be year of publishing, so any attribute of this row. Cell is exact data filled into this attribute field. So if our attribute is publishing year, so it's like 2025 is your cell. And the whole thing is your table. Okay, so I already talked a bit about it. So what is primary key? You can see this picture where you have two tables. One is users, other one is tasks. So in both cases, you want to be sure that you have exact user ID. And that is why you need this unique identifier. So primary key is your unique identifier in your table. The same with tasks. When you are working with tasks and you are creating a new one, you assign an ID. You already did that in your application, but without databases. So you want to be sure that this task has unique identifier. And here you can see a code snippet just for you to understand. We will get back to it. For example, when you create a table, there is like a keyword in this SQL that is called exact way as it is, primary key. So you can see it in red, and you have to use it when you want to say that this exact field want to be my primary key in your table. Yeah. Okay, it also will be a bit later, but I can explain now. For example, you had in your application when you insert your row and you have auto incrementing. So you want your ID always to be computed that it is 1 plus previous value. So serial is like auto incrementing. If you're so if your rows have like 1, some book, like book name, second book name. So when you are inserting a value, this table understands that it should be 2 plus 1. So that is serial. And that is why you can use it a bit to automate it. So to not depend on your things and thoughts, serial will do work for you. Just auto increment it. Okay, so as we have primary key, we also have foreign key. Foreign key is a bit more complex thing, and it can help you, again, this case with user and tasks. You can have your user, and you have unique identifier for user. And when you are creating your task, it's like at university, you want to assign it to some user to do this task. So how to connect these two entities? That is called foreign key. And the foreign key looks like best practice is to name it with your table name that you are referencing an ID. Why? Because you will understand what this field means. So in your tasks table, that is user ID, and it references the user. So how it works? When you are creating a task, you can put this field. You have to specify that that is foreign key, or you can use a shortcut with references. We also get back to it, it's okay. But yeah, for now, you just have to understand how it works. So it connects the tables together. And if you have your task, you want to assign it to a user, you have to specify user ID. And why to use it just you can just put any ID there and it will work. Yes, but to ensure that your data is connected and stable, you have to put this preference so that you know that if you create a task, the user you connect it to exists in your table and really exists, and it's not just a magic number. So that is why you need foreign key, and name is actually self-explained. Foreign key means that you are referencing something that is not in your table, like foreign. So that is why it means a reference to other table. And having our primary keys and foreign keys, we actually can create relationships between tables. And you can see here basic examples, like one-to-many is like teacher to students. One teacher can work with a lot of students. So that is why you need foreign key, for example. So in such way, you can connect student entity to teacher entity. Also, for example, second thing is your course. And you have a lot of students. So students can go to many courses via enrollment to these courses. So we need like one more step to register the student. For example, you have some courses table like math, physics, and you have your students. So both Alice and Rob can go to math and physics. So that is why you need your table. For example, that will have rows like student ID, student. So that is why you have to do this in a separate table, in a separate place, because you actually have two courses and two students, for example. But as I said before, both Alice and Rob can go to math and physics. So Bob can go to math, Bob can go to physics, and Alice can go to math, Alice can go to physics. So you have to specify that in a separate table in order to ensure that both of your tables are reused and that all the students can apply to all the courses. And also, one more thing is one-to-one relationship. Here, that is an example with account. For example, you have only one account in your student system, so you don't have a lot of accounts. And this account is only yours account. So you have one account, and this account have only you. So that is why it is important. So that we can also ensure that only one account is related to only one student. Okay, so here is just an explanation how the queries work. You have some thought that you want to get some data. And for example, that is not only just return me all the tasks that I have in my table. For example, you have a request to get not completed tasks that have a description. So these things in your request, they already talk about the filters, that you have to apply some filters to your data. And when you construct your query, you have to add these filters. Not completed tasks, where status is not completed, and where description is not null. So the description is present. But yeah, we also will get to it in a bit more details. So you create a request, you create a query, the query goes to the database, and you get some data, your application actually, but here's just a person. Yeah, so now we will dive a bit deeper into all of that. As a database server, we will use PostgreSQL. Why? Because it's really a powerful engine for databases. We will install it during classwork, so don't worry for now about it. Yeah, so why to use PostgreSQL? Because it is used in really like production-like systems and production systems too. It has a lot of extensions. So if you need some additional behavior, you can add it. It is really well supported. And it's just a really powerful database that works with a lot of data structures and data types. So that is why our choice is PostgreSQL. Installing is not hard, actually. You just should go to official PostgreSQL website, and you will have there like a file, or if you use Homebrew, you can just install it via 2 commands. But we will do it later. So just how to work with Postgres. You will install it and you will have it available in your terminal. So to do something, you have to go into PostgreSQL terminal from your own terminal. So that is why you have this command. It is psql u postgres. What it means, that your PostgreSQL by default create for you like a super user that can do anything. It's like admin. And this username is Postgres. So when you are creating all of your other databases, your like boxes, which will have a lot of tables inside, you have to use this shell, like an admin, to create this database. That is just a way how Postgres organizes it. So to create database, you have this command, create database, and some name that you choose. Why do we use here uppercase? It's actually more just a decision than a really like needed thing. You can use it lowercase, like create database can be also lowercase, but in all the queries, in all the things that you do with Postgres, all the like service commands that are doing work for you, it's really important to make them uppercase because that is just easier for you to see. So that is like some conventions that we have in Python. Something is really like required, something is just a best way to do this. The same with SQL. It's better to use uppercase syntaxes because if you have a really large query, you can imagine it like with tons of filters, it would be hard for you to distinguish some service commands and like filters that you are putting and your fields, their names and their tables. So use it uppercase, just a tip. Okay. So creating a table. We can do this, of course, via graphical user interface, but we will do it just via shell for the first time. What our query has. It has the request itself, create table. After that, we have table name. Here it is example with tasks. And then in parentheses, we have to specify our fields and their types. That is really important because after that, your field will have a particular type and you will not be able to insert something other into it. So how it works, for example, here we have ID field, which is serial primary key. Serial is auto increment. Primary key is a unique row identifier, as we already discussed. And then we have other fields. For example, title. We understand that it's like a text value. It's like a string value in your Python program. So that is why we put this data type. And we also can specify if the field is nullable or required in your program, you had it already, or it's not nullable. So that is why we are putting it also. If we are not specifying that it is not nullable. If we are specifying it, it is nullable. So If you don't put anything, it's not nullable by default. And if you put null, it is nullable. You can also explicitly say that it's not nullable just for you, but by default, it's not nullable. So if you don't put that it's nullable, a field should be filled in, so it is required. Then we have here status field, and we can also use such keyword as default. What it means that some value will be also like filled by default if you do not specify anything other. So, for example, when you create your task, just logically, when you create a new task, which status it will have? Not completed, probably, so it will be new. So you can set it on your database level to make it easier for you during like programming all the other things. So the database would just know that a new task should have new status. Yeah. And also we have also other fields, for example, progress. Real is a single precision floating point number, as here I said, but what it means, it's like float in your Python program. So you can put their non-integer numbers. Yeah.
SQL what Boolean?
Yeah, of course. It is Boolean field. So you can learn more about all the data types. It's like PostgreSQL has really good documentation, so you can just go to the website and find any field that you need. They have really complex things, and I hope you will not need them for the first time because it's really hard sometimes. Is it visible? Yeah, I think we can practice a bit and create our table, first table. So, for example, I don't know why it makes it lowercase by default, but it's okay. For example, I have already tasks table and users table that is filled with some test data for us. But I want that my users have also notes when they can like put their notes and just while they are making tasks, they will have some place to put their thoughts into. So create table notes. Our table notes,
Yep.
I can try.
Well,
For her. Yeah, it works. Thank you. Yeah, create table notes. So, for example, our node will have an ID. It will be serial, auto-incremented, and it will be primary key. Then make it easy, I think, for first time, title, or maybe even description. Let's put description. Oh. And then we want our node to be connected to a user. So we will put user ID. And what we have to do next is to specify the data type. In my case, it is UUID. You also used it in your program. It can be integer or any other value that you use. And then you have to put references. What it means that we are creating a foreign key that reference some table. You have to put which table to reference and which field to reference. So let's try to run it. Okay. 1 second. I think I have some issue here. Okay, good. Okay. Yeah, so it was a syntax issue. As you can see, our command is successful. So we will get a message about it. And now I can go, probably I have to zoom in too, but I don't know how. I hope you can see. I got my table and we have here actually 3 columns. It is ID, description, and user ID. That references particular user. So let's get back. So we created our table. If you do it using shell, it will be, we will have a command to check to the created table. So you are working in general shell, but then you can go to your particular table and just list all the records that it is successful. So yeah. The next part is SQL clauses. So you have now table, but that is just like a box that is empty for now. You have what you can put in your box, and to actually put your values into the box, we have our insert statement, and the syntax is on the slide. You actually have to use insert into, specify table name. After that, you have to list all the fields that you want to insert, and then the values that you want to insert into these fields. You can see there that you can insert multiple rows. For example, here one task is onboarding new student, other is prepare slides. So you can insert both rows at one query. And important notes about this, that the sequence matters. So if you specify your fields, title, assignee, status, so when you are inserting your values, you also have to follow this sequence: title, then assignee, and then status. Because the data will be just not structured well. And also about quotation marks. For some reason, when we are inserting the data, we have to use only single quotes, because with where is it? Okay. It will not work if you use, I'll just maybe write this, insert. So that is important just on your database level. SQL enforces that inserts are used with single quotes. So only single. Okay, I think we have to also try to break it, I would say. So we created a table. We already have our table notes with such structure. I can maybe leave it for you just to have a reference. That is, by the way, a way of commenting things. Like, as you can comment the code in your Python program, the same you can do in your SQL shell by using these just 2 lines. Okay, so let's try to insert the data. Our notes table have what? ID, description, user ID. So we are writing these fields: ID, description, user ID. And then we can put which values we want to insert. For example, ID is integer. I will insert 1. Description is a text field. And then goes user ID. So as you see, I use like not singular. So we will have errors soon. Okay. For example, I have some user. I will just use an ID. And let's try to run it. As you can see, it identifies it as a column for some reason if we use these 2 quotes. Yeah, so let's switch it to singular. And it works. So that is like a golden rule. And we can refresh it. And we have our inserted row. I hope you can see at least something there. But for some reason, it is not changing. Okay. So let's go back. The next thing is update. The same way as you can insert a new data, you can update an existing row. But you have to know which row you are updating. So that is the syntax of the query. You have to specify the table that you want to touch. Then set is what you want to change. For example, here we are changing field progress to 0.8. And then we are changing status to completed. So you firstly specify the table, then you specify the exact fields, and then you have to apply filtering just to know which row you are updating. And in most cases, it's like a basis. You will use ID field because it's unique identifier. And that is why here we are updating the tasks with ID 1, so it will be 1 task. And then we are changing progress and status fields. So yeah, we can also try it. I will also leave it for you. So our update query. Update nodes. Set what we will change. We don't have much things. Set, let it be description. Description to new description. And then we have to know which task we are updating. In our case, it is also where ID equals 1. So in such case, let's try to run it. I think it's successful. Okay. Okay. And we can see that our description was updated to new description. So that is the way to update your existing rows in your database. That can be thought of as your patch query or put query in your like fast API application when you have to change one thing that you already have. Okay, and as we have insert, update, we also have delete. So we can delete the rows from our database, and that permanently deletes data, and you don't have any undo button. So you really have to think what you are deleting. And actually, this image that you forgot the where clause, like generally, in most cases, databases do not allow to run even this, like delete without where. If you use some database manager, as I showed you the interface where I work, and it also has some shell. So basically, some things protect you from that, But as a developer, of course, you have to think what you are running in your database. So be careful with it, because running delete without where can delete everything from your table. And yeah, it's really a thing to remember. Yeah, and as we already created, updated, and deleted our data, we also can run some get queries. But get is a select in our database. So to select something, we may not need all the fields. Like we may have 30 fields in our tasks. But to show it to a user, we, for example, want only ID, title, status, priority of the task, and that is enough for us. So using select, we can specify which exact fields we want to retrieve from our database. Yes. So the next thing is where, that you already seen a bit. Of course, select will be in all the queries that are reading the data from the database. So you'll just have a chance to see it a bit more and maybe learn it. But here the focus is on where, and you can see it in red. What is where? Where is like a filter. So to filter our data by some field and exact value in it, we can use where. For example, here we are selecting title, status, assignee from tasks, but we don't want all the tasks that have title, status, and assignee. We want exactly the tasks that are in progress and which have high priority. So some student is working on them and it's in progress. Yeah. So that is why we need where. So we can predict our output. And if we are creating some application, for example, you can think of it as a filter at the top where the user just enters the interface, and user wants like to see all the tasks that are with high priority. Applies that filter, your program understands it, runs a query, and we get the result. Okay, order by. That is actually self-explaining. So you can think of it as of this thing that helps you to organize your data in like right sequence. Often this field is used with some timestamps. When you say, for example, the task was created today at 10 a.m. and you have this today 10 a.m. as a timestamp, and then you want to order your tasks by this field. What is important here, that to order tasks, you can apply ascending order and you can apply descending order. So ascending order is earliest first, descending order is reverse. Also, one thing that you will use a lot is count. Count helps us to figure out how many tasks we have in this case. So we can just count by one exact field. That is actually the fastest way to do it, because we can have all the table and we can like just count all the records, but to count the records, we can only count by ID, for example. So in such case, if we have 7 tasks, select count ID from tasks will return us number 7. It's like pretty easy thing, but it also helps a lot. This one is a bit more complex. Group by and having, they are also used together. You cannot use having without group by, but you can do other way. You can use only group by without having. So what it does, group by helps us to group our records by some field. For example, we have a same assignee, like in 5 tasks. They are all assigned to a one exact person. And we can just group these tasks by the person. And having is like where when you apply group by. In this query, for example, it helps us to filter those assignees that have tasks more than one. Like when we group the tasks by assignee, and we have, for example, one assignee with 5 tasks and one assignee with 1 task. So having will filter out and return only those assignees that have more than 1 task. So second one will just not appear in the list. It helps us to filter our data after the grouping is applied, because where is not relevant at this stage. But yeah, to understand it deeply, it's really important to practice. So I hope you will get time to do it enough. Yeah. Also, the sequence. It's important thing because all these things like running queries, they require memory and some time, of course, of your computer. So by applying correct order of your filters and your grouping and your having and all the rest things, you can speed up your queries a bit. So what I mean is, like, imagine that you have 20 books. And of course, you want to group them by some author. But you want to group only books that have more than 200 pages. So it's better to just remove books that have less pages than 200 and then group them, instead of doing vice versa, because you will just do it longer. But with 20 books, it may be not so relevant. But if you have 1 million rows in your database, it is relevant. So yeah, just think about applying things. It actually works logically. So if you are building a query, just take a bit more time to think which order I have to apply my filters to get the result, just to make it sound really logical to you. And you should not do any extra things. So yeah, it's important to just see the query and think about how it will be executed. Also, an important thing is join. It actually uses our foreign keys that we created before. And how it works, for example, our tasks table has a connection with our users table. And when we are building some page, we want to show all the tasks with users, just everything all together. So we can make 2 queries, we can somehow connect it, we can do all of that separately. But to really make it faster and to make it more efficient, we want to extract this data at one go. For that, we need join. So it actually joins 2 tables or even more. It depends on your request. And it helps you to correctly fill the rows that you want to show. Here, actually, this image can explain it a bit better. Like, imagine that you are building this tasks interface and you want to show the name of assignee. You will probably not store it in task because that is just user and that is a task. And you don't have to store user data in your task table because that is also actually a principle. Why do you need databases? To store the data separately and correctly and to make it reusable. So you will store your user data in users table, and after that you want to use it in your tasks overview. So you just have to join user table when you are extracting tasks to show the name of that user. So yeah, that is how it works. But actually, joins can be different. And it's not only just a join, it can be inner join. How it works, inner join shows you only matched pairs. And it will mean that if you are extracting your tasks and you have, for example, a task that is not assigned to a user, and then you join your users, you will get only tasks with your users. So inner join works like a two-way filter. When you are joining two tables, you will get, as a result, only those rows that appear in both tables. That is why it's like inner join. So the result will be only tasks that have the user assigned, and this user exists in the users table. Then you have also left join. What is left join? It depends how you build your query. For example, here we have firstly select users. So left is our first table that we are specifying. So left here is users, and then we are joining tasks. And tasks are already like right, second table. So left join will leave all the records that are in users table. So you will get all users, even if they have no tasks. Just a new student, for example, and it has like no tasks. So this row is not assigned to any task, but it will appear in your response because you used left join, so you prioritized your users. And what about the next thing? We have also right join. How do you think, like, what we will get as output with right join? Yeah, it can be possible if you build in such way, but in our case, it's not impossible. So yeah, it's correct. We could get tasks without user, but for us, it is not impossible. Yeah. So actually, oh, sorry, what I done? Okay. Okay. So I hope you can see this data really well. What about, okay. So you can see my tasks table. I have ID, I have user ID. This field doesn't matter. I have also table, description, status, priority. So all the fields that we talked about. Yeah. So let's try to build some queries with this tasks table. I can open it with some structure for you that you can see better. Oh, I think it's really visible. Okay, so let's try to filter our data. Let's try to think about some condition that we want to get as a result. How can I filter tasks that are in progress, for example? Yeah, correctly. So we want to filter using where, we want to filter where the status is in progress. So we put like from tasks from the table that we are searching in, where status equals, and it's important for us to just have the same style. So when the status is in progress. And we got an ID 1, 3, 7, 8, 12, and 16. Maybe let's put also title to make it a bit more visible for you. So we have a task onboarding new manager, design landing page, and some other tasks. Let's try to think about a bit more complex filter. Maybe about our started at time. Let's try to use our ordering. Do you have any ideas what we can put there? Yeah, so to build the query in such way, we can just leave select, title from tasks, where status is in progress. We can actually remove that and add just only our order by, but we can leave both because we can create a complex query and it will be not a problem for our database to run all of these conditions and filters all together. So we can use just order by, started at, and by default, it will be ascending. We can try. Actually, it's better to add the field we are searching by. Yeah, so we have our ascending order. Here it's like a difference with just nothing, actually. So I think I have to corrupt it a bit to make it maybe better for us. So let's try to run this query one more time. Okay. Oh, I see the difference. So we have our ordering started at, for example, that is like 8th of October. And then the last one that we have is 10th of October. So it orders by this started at time, and by default, it is ascending. We can actually put it ascending, and it will not change anything. What have I done? Okay. And then we can put also as descending. I don't see the output for some reason. Let's try to do like this. Yeah. So we can also use it with descending, and we will have the first task that is like the latest one, and the last one that is not the latest one. For example, here it's like 8th of October is the last. Okay, so let's proceed, actually. I don't know why I exited. Okay. That were actually the basics, because the SQL is really a deep topic, and as you will proceed with your developer career, you will face a lot of difficulties and a lot of problems. For example, just a case for you to imagine when both people are changing the same thing at the one time. It's hard to imagine maybe when this like milliseconds difference, it always exists, but there can be the case when two people are trying to update one database record, and it's okay if that is just a task, yeah. But if it is financial system when you have your payments, for example, and you want to accept your payment, and your payment will go to the bank, the transaction will be executed. If two people do this at the same time, you can get like two transactions instead of one. So money are lost. So it's really important. And the SQL has a lot of things to prevent it, to organize it correctly, and also a lot of different problems that you may have. So if you will get a time and problem, you will definitely learn about it a bit more. But actually, such things as select, insert, update, delete, where you will use them like really often just to work with your data. The next topic is indexes, and I can explain it in such way that imagine that you go to your library and you want a particular book. And for example, that is a book of Stephen King, and you just say the person like, I want a book of Stephen King. And the person already knows where to go for this book. Like, it would be really strange if a person that works in library just will say like, okay, I will go to all the shelves that we have and search for this table. So the data is basically organized in that library in such way that when the query comes, and the query is your request as a customer in that library, sorry. When the query comes, the person that works in library already knows where to search for this book. So the data is kind of indexed. It is prepared for that to be searched on. And what is indexed in the database, that is a small ordered structure to help us to find rows faster. So you can see here images. Why indexing is important? Because it really makes the queries faster. So if you are creating an index, you can just save a lot of time if your query is complex, and that is a production system, for example. When you have like million of rows in your database, by creating an index, you can save the time of running this query. So the user will just get the result faster. I think everyone knows when you enter some website page and it's like loading for 2 minutes. It's not okay. So as a developer, you have to experiment with it and just learn how to use indexes. But of course, it can help us a lot, but we have to know where to put these indexes. We can't index all the fields because like what we will get, we will use a ton of memory, but we will not fasten, because if we index all, the database doesn't understand like what is special in that. So we have to apply indexes only to fields that we often use to search for. For example, it can be status. Filtering tasks by status is really often operation, I think, like really common. And also it can be some task title, because you can have a search bar above and you can just type your task status and task name and search in such way really faster. Yeah, that is actually a sad truth about indexes. We can't rely on them in each case because actually they can slow down things, not only make things faster. Indexes work in such way that they like really use disk space. And when you run your select and you have like 3 fields indexed, of course you will get the result faster. But when after that, for example, some administrator or some like person that is authorized to create tasks want to create a task, what happens in our database? We are just removing all the indexes and we are re-indexing everything. So when you add some, 1 second. When you have like 3 tasks, for example, install PostgreSQL. Other is to update system, for example. I hope you can understand what I'm writing here. And the last one is submit a task. And imagine that you have here 1 million of such tasks. So you want to search by task name just to understand how can you fastly find your task and just work on it. So to search by it, you want to add index to your name. But when you want to add one more task and create some like million first task, what will happen? All the indexes will be just cleared, and this operation of inserting this task will trigger the reindexation of the whole table. So it also takes time. That is why you have to think what you are trying to save and if you really need that index, because some administrator or some person that is authorized to create objects of that type that you put a lot of indexes on can experience really slower update or insert operations because that triggers full reindexing. So how to create an index? That is actually a command, create index. Here also naming is important. You have to name your index by specifying IDX prefix. That is also just for you, just for like a best practice, for a good tone of developing, because you have to understand what exactly you are adding to your database. And for indexes, this syntaxes with IDX prefix is important. So to create an index, you have to specify create index, a name of your index that have also contain table name and the field that you are indexing. And after that, you are specifying the table you are applying index to, and then exact field that you are applying it to. So how to think in general about indexes? You should not have a lot of indexes in one table. If you have more than 5, that is probably just a moment to think if something is okay or not, because it slows down the insert operation, the update operations, and even delete operations, which happens really fast, but it can also slow down them. So if your column often ends up in your where filter, it deserves an index, but you have to prioritize. If you are often searching by task status, you can put it like add index and fasten your queries. By title, also you can add, but if you have 10 of such fields, for example, assignee, dates, I don't know, description, you also want to search by description, you have to prioritize what is used more often to search by. Or if you exactly get the request that users experience some slow search for, and then you have to think, do you need an index, or do you maybe have some problems in your query and you want to optimize it? Probably the last thing is explain, analyze. that actually is related to that problems that I told before about slow queries. This thing really helps you to understand how long your query is executed, what exactly happens in your query. So maybe it's not really needed for such query as is in this example, because it's really simple. It's just filtering by assignee, where it has a text of name of this girl that is called Alice. So we are just filtering by one field. But when we have some complex query, you can imagine that with like multiple joins, we are joining 3 tables, we are filtering by 5, 10 fields, maybe grouping something, and the query can get really large, like 200 of lines can be too. So in such case, if something is slow, we don't understand which part it can be. So we really need this explain analyze to really just understand the time of execution, all the indexes that are used, if they are, all the tables, all the rows that are expected or outputted. So this thing really helps you to analyze. And that is probably the first step that you have to do if you get a problem or, for example, a problem that user reported, or you see on your own that something is really slow and you understand that that is on database part. You have to use this explain analyze to just understand what is wrong with your query, to debug it, and to make it faster. For example, we can run it. Let's pick this one, probably. So we are just using this and specifying all the rest of the query. And what do we get? I hope you can see it, actually. Is it visible? Okay. So we get our full, our full query plan. Why I don't see it? Oh, yeah. So what did we have in that query? We had sorting and filtering. So what is cost is just planning and actual time that you were expecting and you got for your sorting. So it's about order by. Sort key started at, as we expected in our query. Sort method, that is not really important for now, but it can have a lot of sort methods depending on complexity of your query. And memory consumption is also important to understand in such case if you are building really huge query. So index scan, as I have index on my status field in my tasks, and it also returns how much time and how much loops it needed. What is loops? When we have our index and we are searching by that field that is indexed, we can have a lot of iterations. For example, algorithm of that searching by index was really like has a lot of fields indexed, and we may need 2 or 3 loops to find the item, like checking for multiple times to find that item. That is still faster than just searching by not indexed fields, but loops can also show us if something is wrong with indexes. So if we have a lot of them, and for example, we get in our output that we had 1,000 loops while searching for one row, it's not okay. Like, we have to change it. Yeah. So the last things we have are maybe the most important. It's like planning time and execution time. So if your query has a lot of joins, it can also have large planning time. So maybe you have to restructure somehow or change something just to sped up your planning. It's not even the execution part. So it's really important to structure query well. And after that, execution time is actually that time that your user can say, like, it's too long. This page is loading too long. So execution time is just overall time that your query take.